In this lecture, we'll talk about the chain rule and how it applies to power functions. But first, before we talk about the chain rule, let's talk about something called inside functions and outside functions. And really, what we want to be able to do here is identify an inside function versus an outside function. And so when I look here over at example 1, it says circle the inside function and put a square around the outside function. So here's my first function, f of x equals 3x squared minus 2x plus 7, all to the 10. And hopefully when I ask you the question, where is the inside function, you say it's right here on the inside. So it says 3x squared minus 2x plus 7. Whereas if I ask you what the outside function is, hopefully you say it's raised to the 10th power. Right? So the inside function is 3x squared minus 2x plus 7, whereas the outside function is raising it to the 10th power. On part B, if you look at it, down here we have y equals the square root of 2x squared minus 3x plus 1. So which is the inside part? So hopefully when you look at this, you say, okay, this is the inside part, the thing underneath the square root sign, whereas the outside part, of course, it's kind of hard to circle the square the radical, so I could just, I'll just put a square. This is the outside part, that square root. It might be a little bit more obvious if you write this as 2x squared minus 3x plus 1, all to the 1/2. Then it's a little bit more clear that this is the inside, whereas the 1/2 is the outside function. Later on, we'll be doing this with sines and cosines and e's and ln. So, I think an example here might be ln of, let's do x squared minus 3. The inside piece would be this x squared minus 3, where in some sense the outside piece is the ln function. If we do, let's say, e to the x times sine of x, all in the exponent, the inside piece turns out to be this x sine of x, where the outside piece turns out to be the e. And so hopefully this made a little sense, because in order to do the chain rule, we really have to be able to identify inside function versus outside function. And the reason for this is as follows. If you look on your rule sheet, you'll see the chain rule. And it's one of the more complicated rules. It's probably the one that's the most confusing really to students. And so it says d dx of f of g of x. So we have g of x inside f of x. So if I was going to identify the inside and outside function for you here, the inside function I'll just underline in green. So g of x is obviously the inside function, and then the outside function is what's left over, just this f. And so what it says, the chain rule says, take the derivative of the outside, so f prime of g of x, and then multiply, then times the derivative of the inside, g prime of x. And so the saying is, and I always just say, the chain rule says the derivative of the outside times, oops, let's get the outside on there, right? So the derivative of the outside times the derivative of the inside. And so let's make sure you see how these parts match up. So the derivative of the outside right here is just this piece. Right, the derivative of the outside, notice you have f prime of g of x, and then you're multiplying So we're multiplying here. So times. And then we have the derivative of the inside. So down here, the derivative of the inside matches up with this piece right here. So derivative of outside times derivative of inside. Let's take a look at an example of how this works. So in example 2, we want to use the chain rule to find the derivative. Now notice these are the same functions we just did above when we identified outside versus inside. So on part A, first I'm going to identify the inside piece. So here's my inside function. And then I'll identify my outside function, so to the 10th power. And this will help me find the derivative. So I know, let's just copy this down. So f of x is equal to, I have 3x squared minus 2x plus 7, all raised to the 10th. My inside piece, like I said before, is this 3x squared minus 2x plus 7. And then the outside piece is this thing raised to the 10th power. So if I want to find the derivative of f, I know I'm going to have to use the chain rule because it's a function inside a function. So I have f prime of x is equal to, and so it's the derivative of the outside. So the outside function is this 10th power here. And so the 10 comes down, and I just times whatever's inside here. So 3x squared minus 2x plus 7, all raised to the 9th power. So that's the derivative of the outside. And then I'll multiply by, and I say the derivative of the inside. So here's my inside piece, this 3x squared minus 2x plus 7. So times the derivative of 3x squared is a 6x, it's just a power rule, minus 2. And that's my answer. You could leave it like this. I guess you could pull out a 2 here because they do have a 2 in common. So I could write this as 10 all times 3x squared minus 2x plus 7. I could pull out a 2 here, so 2 times 3x minus 2. And then I could take that 10 and multiply it by, the 2 and get, 20. Oh, this is to the 9th power. Don't forget the 9th power. So I take 20. I have 3x minus 2. All times is 3x squared minus 2x plus 7 to the 9th power. And that's my answer. Take a look and make sure you see the parts here, how they kind of match up. All right, so up here, I had the derivative of the outside. That's my first term. And right here is the derivative of the outside function. And then I multiply by the derivative of the inside. So here's the derivative of the inside function. And the rest is just some simple algebra. On part B, what do I have? So on part B, it says y is equal to the square root of 2x squared minus 3x plus 1. Now before I can differentiate this, I better write this as a power because the only thing I can take the derivative of at this point are constants and powers of x, basically, or powers of something with this chain rule. So I have the quantity 2x squared minus 3x plus 1. If I write this as a power, it's to the 1/2. And now, since it's written as a power, I can apply the chain rule. So first, let's identify my inside function. So here's my inside function. And then my outside function is this square root, this 1/2, raised to the 1/2. And so now below it, I'll write down y prime. Y prime is equal to, so derivative of the outside, so the 1/2 comes down. All times is 2x squared minus 3x, and then plus 1. And then raised to the 1/2 minus 1, so that's a negative 1/2. So that's just the power rule. And then times the derivative of the inside. So this is my inside function. So the derivative of the inside, derivative of 2x squared is 4x, minus the derivative of 3x is just a 3. And of course, the derivative of constant, 1, is 0, so I just don't write it. You could write plus 0, but it's just the same thing. And I'm basically done, but because they gave it to me in this radical form here, so right here they gave it to me in radical form, I'll put it back in radical form. So what I have is a 4x minus 3 on top, all divided by, I have a 2 on bottom because it's 1/2 here. So 1/2 means put a 2 on the bottom. And then this minus sign means to put this downstairs, so I have the square root of 2x squared minus 3x plus 1. And that's my answer. Again, pay attention to the pieces here. If you look real closely, I have, for the chain rule, this is the derivative of the outside, right here. And then I am multiplying by the derivative of the inside, right there. I made a mistake up here in part A. This right here and this right here, they should not be 2's. These really should be 1's. When you pull out a 2 from 6x minus 2, you put a 3x here because 2 times 3x is 6x, and you put a 1 here because 2 times 1 is 2. And so there should be a 1 right there. All right, so after we get comfortable with this, then we want to talk about how do we use these rules together. And what I mean by this, how do we use the product, the quotient, and the chain rule in tandem? So let's take a look at some examples so you can see how this is going to play out. So if you look at the first example here, so this one right here, what you're going to notice is that you're going to have to use a chain rule because you have this to the 6th power, and this is the 4th power. And you're also going to have to take a product rule because when you say this, you can say it, you'll say you're actually multiplying. You'll say times, so 4x minus 3 to the 6th times x plus 1 to the 4th. So there's going to be a product rule involved here. Now, what we usually struggle with is which rule do we use first. So let me write this down. So I have f of x equal to 4x minus 3 to the 6th all times x plus 1 to the 4th. Now, I see I'm going to have a product in a chain rule. I'm not going to have to use a quotient rule because I don't have a quotient. If you look at part B, it's obvious you're going to have a quotient because you're dividing right here. So I can either choose to use the product rule or the chain rule first. Now, one way will be correct and the other way will be wrong. Now, if you choose to use the chain rule first, realize you have to choose which one you're going to apply the chain rule to. Are you going to apply it to this first function here? All right, let's use the highlighter. So am I going to apply it to this first function here? Or am I going to apply it to this second function here? Because you have to make a choice, you have to realize the chain rule will only apply to one of these and not the other. Whereas if you choose the product rule, if you choose to use the product rule, you'll be using both of these because your first function, what's your first function? Your first function will be this thing, 4x minus 3 to the 6th, times your second function, which will be x plus 1 to the 4th. So the first rule we'll use is the product rule, and as we use the product rule, we'll use the chain rule inside it to take the derivative of these first and second functions. All right, so let's take this derivative, so I'm going to apply the product rule to it. So the product rule says this is going to be equal to, the derivative is going to be equal to the derivative of the first. So here's my first function I circled in green, and so the 6th is going to come down. So now I'm using a product rule in the first function to take the derivative of it. So 6, 4x minus 3 to the 5th power, that's the derivative of the outside, and then don't forget, multiply by the derivative of the inside, which is a 4. And here's my inside function, so derivative of 4x minus 3 is just 4. And then I'm going to multiply by the second, so x plus 1 to the 4th. And then I have plus the first function, which is 4x minus 3 to the 6th, and then times the derivative of the second function. So remember, the second function is this one in red, and so I have to use a chain rule. So the 4 comes down to the outside, so 4 times x plus 1 to the 3rd power, and then times the derivative of its inside, which is just 1. All right, so let's go through this again and make sure we understand all the various pieces here. So first, big idea, I'm using the product rule. So if you look here, what you're going to see is that I have the derivative of the first. So let's put that in a big circle and put a prime above it. So there's the derivative of the first. And then I'm multiplying by the second. So here's the second. And then I'm adding the first. So over here I am adding the first function, and then I'm multiplying by the derivative of the second. So we'll put a square around it and put a prime up here. So that's just a product rule. Now inside the product rule, when I take these derivatives, I'm using a chain rule. So here you'll notice that this is a derivative of the outside. So the outside function is to the 6th power, so I take its derivative, which I get 6 times f4x minus 3 to the 5th, and then I'm multiplying by the derivative of the inside, which is 4, because the derivative of 4x minus 3 is just 4. And then over here, on the derivative of the second function, I'm using the chain rule again. This is the derivative of the outside, and then this is the derivative of the inside. So this is really a product rule with a chain rule inside it. Let's take a look at part B now. So on part B, it's actually going to be a, well, I know I'm going to have to use the quotient rule and a chain rule on it. So y is equal to, and I know this because, well, for one, I'm dividing, so that means I'm going to have to use a quotient rule sometime. And then on the bottom, I have the square root of this quantity, 1 minus x. All right, so before I can even get started on this, I need to write that bottom as a power. So let's write this as 2x divided by, and then this would be 1 minus x to the 1/2. Oh, hold on. Let's go back. I forgot to actually finish this off. I started explaining this to you guys. I need to simplify this expression. So we still have a lot of work to do. That's why I changed positions here so we'd have more room. So let me delete this and come back. I forgot. I got busy explaining what we were doing, and I forgot to simplify this. So the next step, the derivative is done. All right. Now we have to simplify this puppy. So this is not an easy thing to do. So to simplify it, but we follow these simple rules. You'll see if you follow these basic rules, this basic algebraic rules, it's not hard. So we have 6 times 4, so I'm going to combine the numbers. So what I have here is 24, and I have 4x minus 3 to the 5th, and I have x plus 1 to the 4th. Right, so what I'm doing is I'm simplifying my expression. So I have 4 times 1, so I'll put the number here. So I have 4 here, and then 4x minus 3 to the 6, and then I have an x plus 1 to the 3. Basically, I'm cleaning it up to make it nice. So now it looks a lot nicer. And now the next step in simplifying is you factor out what they have in common. So you look at the two numbers at 24 and 4, and you realize that these have a 4 in common. So I'll be factoring out a 4. I look at the next term, which is a 4x minus 3, and they have a 4x minus 3 obviously in common. And you always factor out the lowest power. So that one has to the 5th power, this one has the 6th power. And so the rule, factor out the lowest power, so I'm going to factor out a 4x minus 3. And obviously 5 is smaller than 6, so I'll factor out the 5. And the next term, they have an x plus 1 in common. So I'm going to factor out an x plus 1 to some power. Again, I look at their powers. This has to the 4th power. This has to the 3 power. And so I'm going to factor out this cubed. And I play this game then. Something goes here plus something goes here, such that when I multiply these somethings, I get the above expression back. And let's change the color here so you can kind of see what I'm doing. So the idea is I'm going to take this times something here, and it should give me back this 24, 4x minus 3 all squared, x plus 1 all to the 4th. And so I have a 4 right here. And so I'm going to need a 6, because 4 times 6 is 24. I have a 4x, you see I have a 4x minus 3 to the 5th here, and I have a 4x minus 3 to the 5th here, so I'm good with that one. And then I have an x plus 1 cubed here, but I need x plus 1 to the 4th. And you see I need to the 4th power. And so I'm going to put an extra x plus 1 here. Now when I multiply these two things together, I'll get back this thing on top. And then over here, let's use a different color. Let's use green. Over here, I have to figure out what do I put here when I multiply this by that. I get this thing above. All right, so I have a 4, so I don't need the 4, so I'm good there. I have a 4x minus 3 to the 5th power here, but I need to the 6th power. So what I'm going to put here is a 4x minus 3. And then over here I have x plus 1 to the 3. And what I need is an x plus 1 to the 3, so I got it, and I'm done. Okay, so if you notice, this right here times this thing, if I can draw, right there, times that thing, will give us this thing right here. All right, so I'm almost done. The last step is to simplify on the parentheses inside here. So what I need to do is I need to multiply through by that 6. So notice this is a 6x plus 6 on the inside. Then I have plus 4x minus 3. And so 6x plus 4x, I have a 10x. And then plus 6. And then minus 3 is a plus 3. And so my final answer, this will be equal to, I have a 4. I have 4x minus 3 to the 5th, all times x plus 1, quantity cubed, and then all times 10x plus 3. It's very important that you can factor. Later on, we'll basically set these formulas equal to 0 and solve for x. And if you can't factor or you can't simplify appropriately, you'll have a very difficult time solving these types of equations. All right. So now we can come and do this second problem. So let me scroll down here and copy this one down. So part B, we have y equal to 2x, all divided by the square root of 1 minus x. And like I said before, we're going to have to use a quotient rule and a chain rule because we're dividing, and obviously we have the square root over the quantity 1 minus x. But before we can take the derivative, we need to write everything in terms of power. So I have 2x divided by 1 minus x to the 1/2. Now you have a choice here. You can either use the chain rule or the quotient rule first. Depending on which rule you choose, you'll either do it correctly or incorrectly. So notice if you try to use the chain rule first, it only involves this 1/2 down here. It's not going to involve this 2x. And so that would not be the right rule to choose first. We want to use the quotient rule because the quotient rule will involve this high function. And so we have the high function up here. And then the low function, which is in the bottom. So it involves basically everything. So the way I usually determine which rule to apply first, I think which rule applies to everything in this function. And the chain rule will only apply to the bottom part, whereas the quotient rule would apply to the top and the bottom. So I apply it first. So remember the chain rule, it's low d high minus, not chain rule, I'm sorry, the quotient rule minus high d low all over low squared, and away we go. And so right here I'll start y prime is equal to, and then the low function I simply copy it down, so I have 1 minus x to the 1/2, that's the low function, times d high, so times 2, derivative of 2x is just the number 2, minus the high function, so copy down the high function, so that's just a 2x, and then times derivative of the low function, so derivative of the low function is 1/2, derivative of the outside, so 1/2 comes down, 1 minus x to the minus 1/2, then times derivative of the inside, which is a negative 1. Remember the inside function is this 1 minus x, and so its derivative is this negative 1. Right? Really 0 minus 1, but we just write the negative 1 there. And then all divided by low squared. So this is all divided by 1 minus x to the 1/2, and then this is all squared. Let's make that 1/2 a little bit better, so 1/2. Okay, so the derivative is done, and the rest is just some algebra. So let's clean this up a bit. So the way I would clean this up is I'd write first 2, all right, the number in front, 1 minus x to the 1/2. I notice up here, so I'm going to do this in red, that I have a minus sign and a minus sign here. So those are going to cancel. I'm going to get a plus sign, so I'm going to get plus. And then 2 divided by 2's, those are going to cancel. And so then I'm going to have an x. And then I have a 1 minus x to the minus 1/2. All divided by. And on the bottom, I have 1/2 to the 2, so exponents multiply. So 1/2 times 2 is just 1, so I have 1 minus x on the bottom. And maybe before I go any further, let me make sure you see the parts of this where the derivatives came in. So here, let's circle these. This is my high function, and then this is my low function. And notice, first I used a quotient rule. So this is the low function, so low. And then I multiply by the derivative of the high function. So this is the derivative of the high function. And then minus the high function times the derivative of the low function. So there's the derivative of the low function, so it's rectangle prime, all over low squared. So there's the quotient rule. And then with inside the quotient rule, we're using a chain rule right here. So I have the derivative of the outside. So my low function is 1 minus x to the 1/2. So the 1/2 comes down. I get 1 minus x to the negative 1/2. And then I'm multiplying by the derivative of the inside. Right? Here's the inside piece. Right? Inside is 1 minus x. So its derivative is just a negative 1. So hopefully you can see the pieces. All right, so back to simplifying. So it looks a lot better at this point. And then now what I want to do is factor out what they have in common. Now, you may at first think they don't have anything in common. They certainly don't have any numbers in common because there's a 2 here. There's a 2 here, and there's a number here, 1. We just don't usually write it. So there's a 1 right there. It's not usually written. But if you look at the next term, they do have a 1 minus x in common. So you have a 1 minus x and a 1 minus x. And it's a 1 minus x to the 1/2 and 1 minus x to the negative 1/2. And the rule is pull out the smallest power. So on top, I'm going to take a 1 minus x and a 1/2 compared to a negative 1/2. Which one's bigger? Which one's smaller, let's say. So the negative 1/2 is definitely smaller. So I'll pull out a minus 1/2. And then I'll play this game. Something goes here plus something goes there. And this is all divided by 1 minus x. So that whatever's here, so whatever goes here, when I multiply this by that, I'm going to get this back. And so let's try to figure that one out. And so whatever is in this red circle over here, I need to get a 2, so I'll put a 2. And then this is the tricky part. If you think about it, I'm going to have to put a 1 minus x here to some power, because I want to get out a 1 minus x to the 1/2 over here. In order to get a 1/2 out, you need a 1 power here, because exponents add. Right, so think about this. If exponents add, then when you multiply this thing right here by this thing here, the negative 1/2 will add to the 1, and you'll get back a positive 1/2, which I guess I have to highlight like this, over here. And then the next term, and so the next term I need to get an x, so I'll have to put an x here, because there's an x right there. And then I don't need anything else, because if you notice here I have a 1 minus x to the minus 1/2, and I certainly have this 1 minus x to the minus 1/2 right here. So this times this gives me this here. All right, so the factoring is done. Let's clean it up right down here so you can kind of see I have 1 minus x to the minus 1/2 all times, and I can multiply through that by that 2, so I have 2 minus 2x plus an x, and this is all divided by 1 minus x. And you can see on top, you're going to get some cancellation. You're going to have 2 minus negative 2x plus an x is minus x. And so my final answer will be equal to 2 minus x on top. And then on the bottom, I'm going to have a 1 minus x. And because this exponent is negative, it's going to go on the bottom too, and so I'm going to have the square root of 1 minus x. And remember, the rule is if you give it to me in radical form, so you gave it to me in radical form here, I'll put it back into radical form for my final answer.